Hi everybody, it's Mr. Oaks. So we're going to continue talking about how to factor polynomials, and we're going to take it up to now what I figure is like the second level. So factoring using Gray's common factor was like a level 1, then level 2 is difference of two squares, so two perfect squares. And one of the good things with difference of two perfect squares is that really all the requirements are in the name, and that's why we have here is it dots. So this is difference of two squares. That's when you see that. So basically what I got to realize is the D represents difference. Always of, I'm not gonna that's of. But then we have 2, and then the S is for perfect squares. So I have that here. So what we want to do first is figure out, well, what does difference of two squares, or dots, what does it look like? So I have here, number 1, we have x squared plus 9. So the very first thing is difference. So when I talk difference is subtraction. So that's what we're looking for. Does it have subtraction? This has a plus in the middle. It's x squared plus 9. So that's a no. So that's not difference of two perfect squares because it doesn't have subtraction. It has two things. They're both perfect squares, but it's not going to work because it's not subtraction. We look at the next one. So we have x squared plus 4x minus 16. So I look at this one. Does it have difference? Well, there is subtraction in it, but there's more than two things. We have 1, 2, 3. This is a trinomial, not a binomial. So this is also not difference of two squares. Then we go to the next one. X squared minus 7. Do we have difference? We have subtraction. Do we have two things? Is it a binomial? First term, second term, so we have two things. So far, so good. The last thing is, do we have perfect squares? Well, x squared is a perfect square because it has an even exponent, and that's going to be important later. But 7 is not a perfect square. So this is also no. Okay? So each of these has something about it that makes it not be a perfect difference of two perfect squares. I have perfect squares. It's two things, two terms, but there's addition, not subtraction, so no difference. I have perfect squares, x squared, 4 x isn't a perfect square. Minus 16, I got difference, but I have more than two things. X squared minus 7, I have difference, I have two things, but I don't have the second thing being a perfect square. Then we get to here, x squared minus 25. It has difference, so it's subtraction. There's two terms, so there's our 2. And both things are perfect squares. X squared is a perfect square, 25 is a perfect square. So this is difference of two perfect squares. So this is one example. This is a basic example here. And what I'm going to do is I'm going to show you what to do in case you ever have to do this factoring. Now, the factoring for difference of two perfect squares is actually really easy, and I'll show you why. So, I have my first one. You see, I got 3 different levels here. X squared minus 25. So once I know that it's difference of two perfect squares, I'm going to set up 2 sets of parentheses. And in each of those parentheses, I'm going to put a plus in one and a minus in the other. And the reason I'm doing this is because difference of two perfect squares, I have to get opposites so that they cancel out. So you know, when we were doing multiplying polynomials, well, when I my outer and inner, when I combine them, if they have they're opposites, then I can just cancel them out, and then I have a difference of two perfect squares. So what I'm going to do here now that I have my parentheses set up, I have a plus, I have a minus, so what do I do next? Well, I'm going to look at my first term, and in this case it's x squared. So what I do is when I have a variable, I take its exponent and I divide that by 2. So I'm going to put an x in the first spot here, I'm going to put an x here, and I'm going to say, okay, well, what's 2 divided by 2? Well, it's 1. So my exponent for each of these variables, these x's, is going to be 1. I don't have to put anything, because it's implied that there's an exponent of 1 there. So I'm going to move on to my next thing, 25. So all I have to say is, well, what's the square root of 25? Well, what number times itself gives you 25? 5. So I write 5 here, I write 5 there, and I'm done. That's it. I have factored completely x squared minus 25. Really not that bad. So now we'll move to the next one, 4x squared minus 49. In this one, we have a coefficient in front of our variable term, and we have, it's a difference of 2 squares. So first thing I'm always going to do before I start to factor this, I'm always going to look, do I have a greatest common factor here? So I'll look at the 4, I look at the 49. Do 4 and 49 have anything in common? No. I can't divide anything that goes into 4 into 49 except for 1, and that doesn't help me. So I'm going to set up my parentheses again. 2 sets of parentheses, plus sign in one, minus sign in the other. So I'm going to do this. 4 is a perfect square. What number times itself gives you 4? 2. So I'm going to put a 2 with room to put the variable at the front here. My variable is x, so I'm going to put an x next to my 2 in both parentheses. Divide the exponent by 2. Again, 2 divided by 2 is 1. I don't have to actually write the exponent there. Then I move to my second term, 49. Square root of 49. What number times itself gives you 49? 7. I write 7 in both, and I'm done. Hopefully you're seeing that this really isn't that difficult, because this was always my favorite. Once I ran into a difference of 2 perfect squares, I was like, yes, easy. I'm getting this done quick. Next one, a little bit more difficult, but still not crazy difficult. X squared minus 9y squared. So this time we threw another variable in there. Still going to basically be the same thing. First, check to see if there's any greatest common factor, and there's not. So I set up my parentheses, put a plus in the first one, minus in the second one. I always do plus minus, but you could do minus plus. The order of that sign doesn't really matter. Minus, plus, doesn't really matter. So again, I look at my first term, it's x squared. As we've already seen, I'm just going to put an x in the front there. Then I look, I come across the 9. What number times itself gives you 9? 3. So I'm going to put that in the front. And then I got y squared. Well, if x squared, square root of x squared is x, well then the square root of y squared is just y. So I get x plus 3y times x minus 3y. That's my answer. Not too bad. one, which, okay, now I'm throwing other variables in there, still not that bad, okay? Let's keep increasing the difficulty, but you'll see why I'm like, oh, it's always going to be easy. So, these last two are, what I should say, can be tricky, but it's still going to be the same steps. 25x to the fourth minus 1. Again, first thing we're going to do we have any greatest common factor here? Answer is no. So, I have difference of two squares because I have subtraction. I have two terms. 25 is a perfect square, 1 is a perfect square, and because this exponent is even, this is a perfect square. It's not always that it has to be a 2. It could be 2, 4, 6, 8, 10, 12. Any even exponent is going to be a perfect square because we can divide it by 2. So, I'm going to go and draw my parentheses, plus, minus. Alright, my Sharpies are dying on me. Nope, I'm going to do that. Alright, and I'm just going to go about this the same way. Square root of 25 is just 5. So I'm going to start off 5, 5. Now I have my variable, it's an x. So I'm going to write x. And then as I said before, what I'm going to do to take the square root of x to the fourth is I'm actually going to divide the exponent by 2. So 4 divided by 2 is 2. So that's the exponent I'm going to put. 2. Okay? So we see 5x squared goes in the front. Then we got the 1. What number times itself gives you 1? 1. So, right at the end. So our answer here are factored completely. 5x squared plus 1 times 5x squared minus 1. Last one. Bunch of different things going on here. So, first thing I do with this 4x to the fourth, y to the sixth, minus 25. As always, I'm going to look to see if there's any common factors. There are none. Is it difference of two perfect squares? I have difference. I have two terms. 4 is a perfect square, and because each of these variables have an even exponent, they're perfect squares. And 25 is a perfect square. So I'm going to draw my parentheses, plus, minus, start taking it step by step. Square root of 4 is 2. So I'm going to put that towards the front of each parentheses. I've got x, I've got y. I'm going to write those down right away. Okay? 4, I'm going to take the square root, and when I take the square root, when I have exponents, is I divide by 2. So 4 divided by 2 is 2. So I'm going to write an exponent of 2 on each of my x's. Now I have a 6. 6 divided by 2. 6 divided by 2 is 3. So each of my y's are going to get an exponent of 3. And that's how you do that. Finally, the 25, square root of 25. Well, as we saw up here, it's 5. And we're done. That's all we have to do. So factored completely, 4x to the fourth y to the sixth minus 25 is 2x squared y to the third plus 5 times 2x squared y to the third minus 5. Difference of two squares, not that difficult. I really hope this was helpful. If you liked the video, please like and subscribe to the channel. I'll be continuing to make these videos as often as I can. Math is everywhere, so you should know it. See you next time.